Hello and welcome to this how-to video on getting started with trackable entities using ASP.NET Web API. You can find more information on how to use trackable entities by going to the Trackable Entities documentation homepage located at tonysneed.github.io/trackable-entities. You can install trackable entities by following the instructions in the installation section, and you can find step-by-step instructions for this tutorial by going to the Getting Started section of the documentation, where you can scroll down and click the link to get started using trackable entities with ASP.NET Web API. During this tutorial, I'd like to encourage you to follow the instructions you'll find on this website for getting started with trackable entities using ASP.NET Web API. For this tutorial, we're going to use Visual Studio 2013. Trackable Entities is compatible with the free Community Edition as well as with Professional or Higher editions. The first thing you'll want to do is to create a new project where you'll find templates for different kinds of Trackable Entities projects. This time we're going to select Trackable Web API Application. You'll want to select an appropriate location as well as a name that you'd like to use for your solution. Next, you're going to want to select the kinds of entities that you want trackable entities to generate for you. You're going to need to choose between separate entities for client and service versus a single set of entities which is shared between client and service. Shared entities require less maintenance because you only have one set of entities to generate and maintain, but here it's going to be easier if you're only going to be targeting clients that run on .NET 4.5 or greater. If, on the other hand, you wish to support clients that run on a number of different platforms, including various mobile devices, you're going to prefer the entities that are separated between client and service. For the purposes of this demo, we're going to choose separate client and server entities with portable entities on the client. What you'll get is a solution that contains 4 projects. The first thing you're going to want to do is to update the NuGet packages for trackable entities to the latest version. You can do that by right-clicking on the solution, and from there selecting Manage NuGet Packages for Solution. After updating the packages, you'll want to build your solution. We're going to begin by generating entities for the service. To do this, we're going to use the Entity Framework 6.x Tools for Visual Studio. To use the EF Tools for Visual Studio, we simply add a new item to the project and select ADO.NET Entity Data Model. Here you can choose either EF Designer from Database or Code First from Database. I would encourage you to avoid the Designer from Database because EDMX-based models will be deprecated in a future version of Entity Framework. Choosing Code First will be prompted to select a data connection. Here we'll create a new connection to SQL Express. We'll simply accept the defaults, and we will choose to import all of the tables in the database. When the wizard finishes running, you'll see a class that extends DB context. Next, we're going to want to generate client entities. Notice that we have a portable class library for our client entities, and it just so happens that Entity Framework 6.x Tools for Visual Studio are not compatible with portable class libraries. And for this reason, we're going to use the Entity Framework Power Tools. And to do that, you can right-click on the project, select the Entity Framework context menu, and from there select Reverse Engineer Code First. The Entity Framework Power Tools will generate entities for all the tables in the database, which is one disadvantage it has over the EF 6.x Tools for Visual Studio. Once the entities have been created, you can delete the DB context class because we're not going to need that on the client side. We can also delete the mapping classes. Next, we're going to need to copy the database connection string from the app config file in our service entities project, and we're going to want to paste that into the web config file of our Web API project. The next step is going to be to add controllers to our Web API project. And to do that, we're going to add a new item to the controllers folder. Here you're going to select the Trackable category, and from there select the Web subcategory. This is where you'll find an item template for an Entity Web API controller. We're going to start by inserting a customer controller. At this point, you'll be prompted to select an entity name. We'll select customer from the drop-down list. You're also going to need to enter an entity set name, which is the plural form of the entity name. This will provide for you a Web API controller suitable for the entity that you selected. Here we have a customer controller with actions for get, post, put, and delete. And the other thing you're going to need to do is replace the int parameter with the data type string, because string is the data type for the primary key of the customer table. You'll then want to add a controller for the order entity. We'll select the order entity, enter order's entity set name, and click OK. In this case, we are going to want to include related entities. So to do that, we're going to invoke the include operator. We're also going to want to include related order details. But to do this, we're going to specify a string instead of a lambda expression. And the reason we're going to want to do that is because not only do we want to include related details, but for each related detail, we also want to populate the product property. We'll then copy those two include statements to the other getOrder method. And we're going to add an overload of the getOrders method, which accepts a customer ID in order to return just the orders for the specified customer. Lastly, we're going to scroll down to the delete order method and fulfill this to-do item by including order details that need to be deleted with the order. In order to test the customer and order controllers, we can right-click on the Web API project, View in Browser, or we can choose to use this shortcut Control-Shift-W. Once the home page is displayed, this will show the help page for all of your controllers and actions. And from here we can click Send in order to submit an HTTP GET request. And here we can see the result that we're expecting. Here we'll specify a particular customer. And while we're here, it's a good idea to make note of the port number in order to paste that into the code on the client. We can then update the code in the console client application and then uncomment code in main in order to invoke our API service from the client. And then we can paste the port number from our API service. The other thing you can do is uncomment the service methods. These are helper methods for invoking our Web API service using HTTP client. And lastly, we'll uncomment a set of helper methods for printing customers and orders to the console. In order to test our client, we can set it as the startup project. We'll press enter and that will retrieve customers from the service. Next, we'll uncomment code in the console client to create an order, update an order, and delete an order. Here we can set some breakpoints in the client. We can also set breakpoints in our controller actions in order to debug this code on the server side. Now we're going to press enter to create a new order. You can see that we're creating a new order from scratch. Notice that instead of populating the customer property of the order, we're simply supplying the customer ID, and we're populating the product ID of each detail without having to populate the product property. Here we're going to post the order as JSON, and then we're going to read the response. And here you can see we've hit the breakpoint in our post order action on the orders controller. Then we're going to call apply changes, which will inform Entity Framework that the order and its details have been added. Finally, we'll call save changes. And lastly, we'll call load-related entities, which is going to populate the reference properties both on the order and the order details. And calling accept changes will simply set the tracking state back to unchanged before returning the entity to the client. And then we can go to the next step, which is to update the order we just created. Here we're going to start change tracking by adding the created order to a change tracking collection of order. We're going to modify one of the details, remove a detail, as well as add a new detail. We're going to start by calling getChanges on the change tracker. This will give us only the entities in the object graph which have been inserted, updated, or deleted, and that will improve our performance when calling the end-tier service because we're not going to be sending unchanged entities over the wire. Here in the put order action, we're going to apply changes, which is going to inform Entity Framework about inserted, updated, and deleted entities. And back on the client, we're going to call merge changes on the change tracker in order to set properties on our entities which have been generated by the database, such as identity or concurrency values. Here in the delete order method, we're going to fetch the order from the database and include any related order details. And that concludes this tutorial on using trackable entities with ASP.NET Web API. For more information, you can go to the documentation website for trackable entities. My name is Tony Sneed, and I'd like to thank you for using trackable entities to add end-tier support for Entity Framework to your Web API applications.